Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are studying topic number 13.7, torque on a current carrying loop or rectangular coil. This is actually coil, COIL. Okay. 13.7, now we are studying torque. So, torque is defined as simply the cross product of momentum and force is called torque. We have already studied this equation, this definition in first year physics in the previous course, in the previous year. So we know that what is torque. So torque is defined as the cross product of momentum and force. Okay. Now uh, there is another force which is called the couple force. So we already studied that when there are two forces which have same in magnitude, opposite in direction, and having different line of action, that is called the couple force. But the formula for the torque in couple force is torque is equal to couple arm multiplied by one force. This is the formula for the torque in case of couple force. Or we can say that the distance between the two forces multiplied by one force. This is the formula for the torque in case of couple force. Okay. Now we are studying a rectangular coil in which the current is carrying and the magnetic force will be acting on this coil, and that magnetic force will produce torque. So we are studying the torque produced by magnetic force. Okay. Now suppose we have a magnet here which has two poles. We have another magnet which has two poles, and there is a magnetic field from north pole to south pole towards right. This magnetic field is called uniform magnetic field. Okay. There is a rectangular coil within the magnetic field. This is the rectangular coil within the magnetic field. Suppose the current flowing is down at this end towards right, towards up, and here current is moving towards left. So here the current is moving down, here moving towards right, here the current is moving towards up, and here the current is moving towards left. Okay. Now we know that the formula for the magnetic force F is equal to ILB sine theta. We know that if the theta is 0, magnetic force will be 0. If theta is 180, magnetic force is 0. If the theta is 90, magnetic force will be maximum. Okay. So magnetic force depends upon theta. So look at here, this current. Look at this current. This current is moving towards right. If this current is moving towards right and the magnetic field is towards right, so both have same direction, so the theta is 0. If the theta is 0, sine 0, 0, force 0. So here there is no magnetic force acting on this current. Look at this current. Look at this current. This current is moving towards left and the field is towards right. So it making an angle of 180 degree. If you put 180 degree, so sine 180 is 0. So magnetic force is 0. So magnetic force is not acting at this end and at this end. So magnetic force acting at these 2 points. Why? Because this current is perpendicular to field. This current is moving down and the field is acting towards right. So it means the magnetic field is towards right and this current is downward. So this current is perpendicular to magnetic field. So maximum magnetic force will be acting on this end. And here this current is moving up and the magnetic field is towards pointing towards right. So a maximum magnetic force will be acting on this current. Okay. Now here the magnetic force is acting on this current at this end. Okay. Now I want to find the direction of that magnetic force, and we know that the direction of magnetic force can be found by Fleming left hand rule. So look at here. This shows the current, and this shows the magnetic field, and this shows the magnetic force. Okay. Now look at here. Suppose here the current is downward. Look at this end. Here the current is downward. The current is acting downward, so the middle finger is pointing towards down and the field is towards right. So the magnetic force is acting upward, means out of the page. Okay. Here the current is moving up, so the middle finger should be pointing towards up. The magnetic field is acting towards right, while the thumb, which is into the page, the thumb is into the page, means downward, vertically downward. So here the magnetic force is acting upward out of the page. Magnetic force is acting out of the page, and here the magnetic force is acting into the page. So if the magnetic force is acting into the page and here out of the page, so this coil will be rotated. So this coil will start rotation. So if the coil start rotation, so it will produce, there will be a torque. There will be a torque. So this torque is produced by magnetic force. Why? Because here the magnetic force is behaving as a couple force. Because one force is acting at this point, which is up. Here another force is acting at this point, which is acting down. So both are opposite direction and having different line of action. So it means this is the magnetic force behaving as a couple force. So what is the formula for the torque in case of couple force? Look, the formula for the torque in couple force is distance between the two forces multiplied by one force. Distance between the two forces multiplied by one force. Okay. Now look at here. One force is acting at this point, another force is acting at this point. The distance between them is equal to the width of the coil. This is the length of the coil. This is the length of the coil, and this is the width of the coil. So the distance between the two forces is equal to the width of the coil. Okay. So I am writing the distance between the two forces as width of the coil, and one force is actually the magnetic force, that is ILB sine theta. Okay, one force is actually magnetic force, so that is ILB sine theta. Okay, now look, length and width are multiplying to each other. So length multiply width, that is called area. Length multiply width is area. So this is the torque acting on the rectangular coil. This torque produced by the couple force. Which couple force? The magnetic force, which is behaving as a couple force. So magnetic force is producing the torque here. So now look, this is the torque on a single coil. If there are two turns, there are two number of coils. If there are two number of coils, the torque will be 2 IAB sine theta. Means the torque will be acting, the magnetic force will be acting on both the coils. So torque will produce 2 times double of its initial. Suppose if there are 3 coils, so the torque produced will be 3 IAB sine theta. So if there are 4 coils, so the torque produced will be 4 AIB sine theta. So if there are n number of turns, how many turns? N number of turns. So in each turn the current is flowing in, on each current the magnetic force will be acting and the torque will produce. So that torque will be equal to, torque is equal to N IAB sine theta. So what is N? N is actually the number of turns of the coil. So this is the formula for the torque for the n number of turns. So torque is equal to NIAB sine theta. Okay, this is the formula for the rectangular coil which has a current carrying I. Okay, now this formula which consists of sine theta, this formula could not explain, cannot explain the mathematical results and the practical results at the same time. Means this formula this mathematical formula cannot explain the practical phenomena. What does it mean? Look at here. Suppose if we have a magnet and if we have another magnet and there is a coil in the magnetic field. So look at here, the current is moving up, here the current is moving down. So this first I am going to discuss the practical thing. Practically practically explaining the torque producing in this coil. So look at here, the current is moving up. So if the current is moving up and the magnetic field is towards right, so the magnetic force into the page means it is pointing vertically downward. So here the magnetic force is vertically down. Look at the magnetic force at this end. So the current is acting downward and the field is towards right, so the magnetic force is acting upward. So here there is a magnetic force upward, here there is downward, so the coil will be rotated. So practically torque exists. So practically torque exists here. Now discussing mathematically, look at this formula. Look at the plane area of the coil. Look at this plane area of the coil. This plane area and magnetic lines are parallel to one another. The magnetic lines and the plane of the area are parallel to one another. If they are parallel to one another, if the magnetic field and the plane area are parallel to one another, so theta will be 0 and sine 0 0, so torque will be 0. So mathematically torque does not exist. While practically experimentally we can say that torque exists, but mathematically it does not exist. So that is the problem in this equation. So we have to change this equation a little bit. So look at here. If we see this coil from the top, if we observe this coil from the top, so we will observe the coil as a line. So this coil will be seen as a line. Okay, this is the axis of rotation of the coil, and the coil is being rotated with certain angle theta, and this theta is called alpha. Alpha is the angle made with the normal. Okay, if the coil is just rotated with a certain angle theta, so with the original position it makes an angle theta, with the normal it makes an angle of alpha. So if we add theta and alpha, so we will get 90. Okay, if we add theta and 90, the complete angle will be 90 degree. Okay, now shift alpha on the other side, so it will be theta is equal to 90 minus alpha. Okay, now put this equation in equation number 1. Okay, now put this equation in equation number 1, so we will get torque is equal to Nayab sine theta. Theta is 90 minus alpha. Okay, so this is the mathematical formula in the first year mathematics. So it will be sine 90 cos alpha minus sine alpha cos 90. This is the formula in the mathematics, first year mathematics. Okay, what is sine 90? Sine 90 is equal to 1. And what is cos 90? Cos 90 is equal to 0. So look at here. Here there is a cos alpha and this is 0. So the formula for the torque is equal to Nayab cos alpha. This is the formula for the torque of a rectangular coil carrying current I. So this formula is accurate because it explains, this mathematical formula explains the practical result very accurately. So this is the accurate formula for the torque carrying current I. Okay, thank you. Take care. Allah Hafiz.